Good morning. Today we are going to see the MAC protocols for wireless sensor networks. First we will see the introduction. The MAC sublayer is a part of the data link layer protocol. It provides the channel access mechanism to several medium sharing devices on a wireless medium which is shared by multiple devices and is broadcast in nature. When one device transmits, every other device in a transmission range receives its transmission. This could lead to an interference and collision of the frames when a transmission from two or more devices arrives at one point simultaneously. Sensor nodes usually communicate via multi-hop paths over the wireless medium in a scattered, dense, or rough sensor field. A MAC protocol manages the communication traffic on a shared medium and creates a basic network infrastructure for sensor nodes to communicate with each other. Thus, it provides a self-organizing capability to nodes and tries to enforce the singularity in the network by letting the sender and receiver communicate with each other in a collision and error-free fashion. Moreover, a typical requirements to increase lifetime of a WSN without the need of any power replacement under human interaction has prompted the development of novel protocols in all layers of the communication stack. However, prime gains can be achieved at the data link layer, where the MAC protocol directly controls the activities of the radio, which is the most power-consuming component of resource-scarce sensor nodes. Efficient MAC protocols utilize the radio judiciously to conserve its energy. Thus, the MAC protocol helps fulfilling important design objectives of WSNs by specifying how nodes employ the radio, share the channel, avoid collision in correlated and broadcasting environments, response the enquirer timely, survive for a long period. Characteristics of the MAC protocol. The characteristics of the MAC protocol can be summarized as transmission delay, throughput, fairness, scalability, robustness, and stability. Goals of MAC protocols: minimize energy consumption, overhearing, unnecessarily receive a packet destined to another node, idle listening, staying active to receive even if there is no sender, minimize the active time, eliminate packet collisions, minimize central packet overhead, prevent buffer flow. Then MAC protocols for wireless sensor networks, specific requirements and design considerations for MAC protocols in wireless sensor networks are balance of requirements. For the case of WSNs, the balance of requirements is different from traditional networks. Importance of energy efficiency for the design of MAC protocols is relatively new and mainly of the classical protocols like Aloha and CSMA contain no provisions towards the goal. Other requirements like fairness, throughput, transmission delay, scalability, and robustness are play a minor role in sensor networks. Energy problems on the MAC layer. A transceiver consumes a significant share of energy. A transceiver can be in one of the four main states. Transmitting in the transmit stage, the transmit part of the transceiver is active and the antenna radiates energy. Receiving in the receiving state, the receive part is active. Idling, a transceiver that is ready to receive, it is not currently receiving anything, is said to be in the idle state. In this idle state, many parts of the received circuitry are active and others can be switched off. Then sleeping, in the sleep state, significant parts of the transceiver are switched off. Energy problems and design goals. First one is collision. Collision is a wasted effort when two frames collide with each other and are discarded because the receiver has to drop the overdropped information. A collision usually results in retransmission and drains more energy in the transmitting, receiving extra packets. The half-duplex nature of the wireless medium precludes collision detection, thereby increasing the responsibility of the MAC protocol. Hence, collisions should be avoided either by design or by appropriate collision avoidance and hidden terminal procedures in CSMA protocols. Then overhearing. The overhearing occurs on the wireless broadcast medium. The node receives the processes in gratuitous packet that is not addressed on it. In the dense network and under heavy traffic situations, this could lead to a serious problem. Control packet overhead. An increase in the number of size of control packets results in overhead and unnecessary energy waste for WSNs, especially when only a few bytes of real data are transmitted in each message. Such control signals also decrease channel capacity. A balanced approach is required so that the required number of control packets can be kept at minimal. Idle listening. Since a node in a WSN usually does not know when it will be receiver of the message, it keeps its radio in ready to receive mode, which consumes almost as much energy as in receive mode. In low traffic applications, this is considered one of the major sources of energy waste. The idle listening consumes significant energy, hence need periodic listen and sleep. Turn off when sleeping. Reduce duty cycle, complexity, and over-emitting. Over-emitting and over-emitting or a deafness occurs due to the transmission of the message when the destination node is not ready to receive it. That's all. Thank you.